In this session, we are going to learn how multithreading works in Java. Specifically, we will understand two different ways of creating threads. First, by using the Runnable interface. Second, by extending the thread class. This is session number 22 of the Java programming course, and I am Dr. Amit Batra. By the end of this lecture, you will clearly know which approach to use and why. Before moving forward, let us quickly revise what we studied in the previous lecture. We discussed what a thread is, the thread lifecycle, different thread states, and thread priority. Today's lecture builds directly on that foundation. Imagine you are a restaurant owner. Would you prefer a worker who can do only one fixed job or a worker who can perform any task you assign? This is exactly the idea behind thread creation in Java. Using Runnable is like assigning tasks dynamically while extending thread tightly couples the worker and the task. We will understand this deeply as we proceed. At the end of this session, students will be able to create threads using the Runnable interface, create threads using the thread class, understand the difference between start and run, decide which approach is better in real-world applications. In today's session, we will cover implementing the Runnable interface, why Runnable is preferred, understanding the thread class, constructors and methods of thread, differences between thread and Runnable, learning activities and assignments. In Java, you can create a thread using any class that implements the Runnable interface. The Runnable interface contains only one abstract method, which is void run. This method must be overridden. The code written inside the run method is what gets executed when the thread starts. Think of run as the entry point of a thread, just like main is the entry point of a program. Once the run method finishes execution, the thread terminates automatically. There are three important steps. First step is implement the runnable interface. Second step is pass the runnable object to a thread object. Third step is call the start method. Important is never call run directly to start a thread. In this example, we have a class hello task that implements runnable. The run method contains a loop that prints the current thread name, a label, and a step count. We use thread.sleep to simulate some work. If the thread is interrupted, we handle it gracefully and exit early. In the main method, we create two threads, assign them names, start both threads, and use join to wait for their completion. Finally, we print done after both threads finish. Implementing Runnable is the recommended and preferred approach in Java. Why? Because Java supports single inheritance only. If you extend the thread class, you lose the opportunity to extend any other class. Runnable allows better flexibility, better code reuse, separation of task and thread. Extending thread should be used only when you need to override thread-specific behavior. Java also provides a built-in thread class. A thread starts execution when the start method is called. Internally, start invokes the run method in a new execution path. The thread class provides many useful methods to manage thread behavior. The thread class provides multiple constructors, allowing us to name threads, pass runnable objects, create threads with different configurations. In this example, my thread extends the thread class. We override the run method to print a counter with the thread name. In the main class, two thread objects are created. Names are assigned using setName. Both threads are started using start. Each thread executes independently and concurrently. Think individually. What is the difference between start and run? Pair with a partner. Discuss when to use runnable versus thread. Share with the class. Run behaves like a normal method. Start creates a new thread. Runnable is preferred due to flexibility. Extending thread limits inheritance. The thread class provides several important methods such as start method, sleep method, join method, set priority method, interrupt method. These methods help control thread execution and coordination. You can go through all these methods and what are the actions performed using these methods in these slides. Key differences. Runnable is an interface, thread is a class. Runnable promotes loose coupling. Runnable allows extending other classes. Runnable is preferred in real-world applications. To summarize, threads can be created using runnable or thread. Run must be overridden. Runnable is the best practice. Thread class is useful but less flexible. In the next session, we will discuss thread synchronization techniques and inter-thread communication. This is one of the most important and practical topics in multithreading. Thank you for your attention. Keep practicing multithreading concepts for better understanding. As the question bank has already been shared with you, related to this session, we are now going to discuss a case-based scenario programming problem. As you can see, a university management system uses multiple threads to handle student registration, fee payment, and report generation. We have to answer these three subparts. First, we have to design a Java program using both runnable interface and thread class to simulate this system. B part is evaluate the advantages of using the runnable interface over the thread class in large scale applications. C part propose best practices for selecting an appropriate thread creation mechanism. So first of all, we'll be designing a Java program using both runnable interface and thread class to simulate this university management system. Again, we will be using the IntelliJ IDE integrated development environment. As usual, we have to click on these four lines, create new button, new project, and you have to give some project name here. And in the left side, you have to select Java and JDK as we have done in the previous session. Then we have to click on the create button, project will be created. So now we will be implementing two Java programs using two approaches. First approach is using the runnable interface. So I have already created this project with name runnable demo. First approach is using the runnable interface. So the name of the project I have mentioned as Runnable Demo because this approach is using the runnable interface. Here. So now I will be explaining the Java program code on the right hand side line by line. Let me hide the project or folder structure so that entire code visible become became visible to you. So first is the student registration class, line number 2. Class student registration implements runnable. So this is the first approach using the runnable by implementing the runnable interface. So class student registration implements runnable. At the rate override is the annotation indicating that the run method is here being overridden. System.out.println thread.current thread.getName plus processing student registration. So this class implements runnable, which means it represents a task, not a thread. The run method contains the business logic for student registration. Thread.currentThread.getName prints the name of the thread executing this task. Then we are having this line number 7, try block, thread.sleep 1000 as the parameter. Then we are catching the interrupted exception thread dot current thread dot interrupt. The sleep method simulates time taken for registration. If the thread is interrupted, we restore the interrupt status, and this is the best practice. Now next line is line number 12. System.out.println student registration completed. This indicates successful completion of the task. Now we come to line number 17. That is the fee payment and report generation classes. First is the fee payment class. Class fee payment implements Runnable. So these classes follow the same pattern. Implement Runnable, define task logic inside run, simulate processing using sleep method. So as you can see here, each class represents an independent service of the university system. So now we go to the this is the main method or main class because within this main class main method resides. So thread T1 is equal to new thread, new student registration, comma, double quotes registration dash thread. Similarly, thread 2 is equal to new thread. Line number 50 is thread T3 is equal to new thread. Here we wrap runnable objects inside thread objects. We assign meaningful thread names. This clearly separates task, that is runnable task, from execution. Task is runnable and execution thread. Now we call the start method T1.start, T2.start, and T3.start. Start creates three independent threads. Each thread executes its own run method concurrently. So now we will be running this first approach, that is using the implementing the runnable interface. By clicking this green button, the build process will start and it will show us the output. So as you can see here, this is the output of the above code. Clear? Exact order may vary due to thread scheduling. Output shows parallel execution, improving system performance. Now, second approach is by using the thread class. So again, we will be creating a new project using in the same fashion. I have named the project as thread demo. I will hide the project structure, folder structure, and now explain this code line by line to you. So the line number 1 is registration thread class. That is class registration thread extends thread. So you are using second approach by extending the thread class. Again, we are having the annotation @override means you are overriding the run method. System.out.println get name plus processing student registration. That is the line number 4. This class extends thread, meaning the class itself is a thread. Business logic and thread behavior are tightly coupled. GetName method returns the name assigned to the thread. Then we are having two classes, payment thread and report thread classes. As you can see, line number 8 and line number 15. Payment thread and report thread classes. Each class extend thread, overrides run method, contains task specific logic. This approach is simple but less flexible. Then we come to the main class because the main method resides within this main class. Registration thread T1 equal to new registration thread. Payment thread T2 is equal to new payment thread. Report thread T3 is equal to new report thread. Three separate thread objects are created. Each object is both a task and a thread. Then line number 28, T1 dot set name registration thread, T2 dot set name payment thread, T3 dot set name report thread. Names improve readability and debugging. Then we are having T1 dot start, T2 dot start, and T3 dot start. Each call to start method launches a new thread. Threads run concurrently. Now again we will be executing this code, clicking this green triangle button, build process will start and the output will be shown in the below window. Again the output order may vary. So all tasks run simultaneously but without simulated delays. Now, what are the key differences visible from the output of these two approaches? We have used two approaches, runnable approach and thread approach. That is by implementing the runnable interface and by extending the thread class. So what are the differences? First aspect is about the task and thread. In the runnable approach, it is a separate. Task and thread are separate. Whereas in case of thread approach, task and thread are combined. Next aspect comes flexibility. By runnable approach is having high flexibility. Thread approach is having low flexibility. Scalability in runnable approach is excellent, whereas in case of thread approach, scalability is limited. Real world use runnable approach is preferred, whereas thread approach is rare. Output detail is more realistic in runnable approach, whereas output detail is basic in thread approach. So these are the key differences. In the runnable approach, tasks are independent of thread management, making the system flexible and scalable. In the thread class approach, task and thread are tightly bound, which simplifies code but limits extensibility. Therefore, for large systems like university management software, runnable interface is the recommended and professional choice. So we have given answers to these all these questions. We have also given advantages of runnable interface over the thread class, and we have proposed best practices for selecting an appropriate thread creation mechanism. So if you found this video helpful, like, share, and subscribe to the channel. Thank you for watching, and I will see you in the next lecture.